Okay, helium in rocks and in the atmosphere. So this is a twofer, and we'll find out that it's actually a threefer. So helium in rocks and in the atmosphere. Let's start with the atmosphere. Helium is pouring into the atmosphere from radioactivity, from radioactive decay in rocks. All right, one of the byproducts, so let's pick uranium moving to lead. One of the additional byproducts from uranium decay, besides lead, is helium. Helium's an inert gas, doesn't combine well with things, and so it escapes easily from the rocks and goes easily into the atmosphere. But gravity keeps helium largely. Helium's very light, but it does keep it from escaping the atmosphere a lot. And we've measured how much helium is escaping from the atmosphere. And it turns out that the total amount in the atmosphere is 1/2000th of that expected if the atmosphere were really billions of years old. So it's like a bucket with a hole in it, but somebody is pouring water into the bucket from a fire hose, right? The bucket should be full, but it's not. That means that the fire hose hasn't been on very long, right? Otherwise, the bucket would be full. So the helium escaping from rocks happens quite fast, all right, as we said. So that's the first part, is the helium in the atmosphere. That proves that the atmosphere, according to this dating method, is very, very young. The helium escaping from rocks happens quite fast, yet so much helium is still in some rocks, right? The rocks where the helium is being generated by the decay of uranium into lead, but it hasn't had time to escape yet. So you have another measuring device, right? Not just how long it takes for uranium to turn into lead, but during that process, the rock is getting filled up with helium, and the helium escapes very easily from the rock, yet it's still saturated. So when you examine the rock, it's off-gassing helium at a rapid rate. And all you do is work back the math. How long would it take for that much helium to off-gas? And it gives you an age of 6,000 years. So it shows up a couple things also. So here's the third item. Where did all that helium come from? Why didn't if uranium to lead is very slow process and there's only a little bit of helium created, why did that helium build up? How is it possible that it could have built up? Only if there had been millions of years worth of radioactive decay that happened only a few thousand years ago. Probably at creation, but if you're uncomfortable with the idea of radioactive decay happening at creation, maybe it happened at the fall, right? When the universe was forever changed because what Adam and Eve did. Maybe then that's when the millions of years worth of radioactive decay happened. So that is why you get radioactive elements that tell you that the rock is old, right? Because there's a little bit of uranium and a lot of lead. So that tells you that that millions of years supposedly have gone by. But we know, in fact, that the presence of the helium, which is also a byproduct of the exact same process, is still stuck in the rocks. And that means that all of that helium was produced rapidly. And it's only been able to off-gas 6,000 years worth of off-gassing.